In this video, we'll start talking about electron configurations in the periodic table. And so at this point, I basically want you to be at the place where you understand that electrons can be described as waves, and those waves can kind of show us where an electron will most likely be found around the atom. They're broken down to energy levels, which is kind of how far apart, how far they are from the nucleus, and also the kind of number of nodes and antinodes in that wave. So kind of some of the areas where the electron is most likely to be found and where it's not. And within those energy levels, there are energy sublevels, which describe the shape of that wave. S is kind of spherical, P is kind of a dumbbell, D is kind of like a four-leaved clovery type deal, F, I don't even know, man, right? And then each energy sublevel has a different number of orbitals or number of orientations, and two electrons can have that same orientation, so 2 electrons per orbital. And the name of the game is stability, stability, stability. So the electrons will naturally be in the most stable orbitals possible. And we kind of saw that, so as you build up, you'll go to progressively higher energy sublevels and energy levels. But the order actually gets kind of tricky. So this is a nice little graphic to have at your disposal. And so all this is saying is that you kind of follow the arrows, and it kind of shows you how you should kind of order electrons. Like, what's the most stable place that they could be? Well, 1s. Okay. Remember that s has one orbital, so there are only 2 electrons that can both be kind of 1s. And the way you would say that would be 1s2 for 2 electrons in the 1s. Then you go 2s. Well, to configure another 2. So you go 1s2, 2s2. After that, well, now you've got 3 orbitals in the 2p, which means you can hold a total of 6 electrons in 2p. So it would be 1s2, 2s2, 2p6, 3s2, 3p6. Now here's an interesting part. We would think that 3d10, right? D has 5 orbitals, so it can hold a total of 10 electrons. We would think that because 3D is at a lower energy level than 4S, that it would be more stable. And that actually happens to not be the case. And there's kind of 2 different things going on. One is energy level, so the lower numbers mean you're more stable, but the other part is the energy sublevel also matters. So S is more stable than P, which is more stable than D, which is more stable than F. So it just so happens that the 3D orbital is not as stable as the 4s. Okay? So then after 3p6, you actually go 4s2. Then the next most stable is 3d10. And then you go along with 4p6, 5s2, 4d10, 5p6, 6s2. And now only at 6s2 afterwards will you get to the 4f. 4f14, 5d10, 6p6, 7s2, onward. 5f14, 6d10, 7p6, blah, 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 blah. Right? And a way I like to draw this is with these kind of diagrams, orbital diagrams. And each line here will represent an orbital. So 1s has one orbital, right? So you can fit 2 electrons here. And we draw that as an up and a down, right? So if you think about why can 2 electrons kind of like be doing the same thing? It's like, well, if one's up and one's down, they're like kind of different, right? So that would be 1s2. If I wanted one more electron in here, it would go here, and after that here, then the 2p's. You'll see that what I'll do is I'll fill each orbital with 1 before doubling up. That's always important. If I want another one, I'll just keep going like this. And so I'll draw all of these in here for you guys. Kind of the order that I'm going. And you can see that I'm following the order over here. 3p4, 3p5, 3p6, 4s1, 4s2, then 3d10. And again, the electrons will be most stable when they're 1 per orbit, and then they'll go and double up after each orbit has an electron occupying it. And so now in the next video we'll start putting specific elements to this so that I can ask you the electron configuration of a specific element, right? And so on and so forth. And again, use this table. You eventually will internalize it.